This example is to compute the Fourier series from the figures shown here, which is from Oppenheim and Wilsky, problem 3.22, figure F. And here I've written on the side what x of t is over the first period. Again, the period here is t equal to 3 because that's what it repeats over. Alright, so for this one we do have to integrate, but we won't have to integrate by parts. So the definition again for a sub k is equal to 1 over t integral over the interval t x of t e to the minus j k omega naught t dt. And again, for this problem, since t is 3, omega naught will equal 2 pi over 3. Alright, so first step is to plug in our x of k, or x of t rather. So we have a sub k equals 1/3 times the quantity. Right, so now x is one of three things. It's either 2 between 0 and 1, it's 1 between 1 and 2, and it's 0 between 2 and 3. So I'm going to have three separate, well, I could potentially have three separate integrals. I have an integral from 0 to 1, and x is 2 in that interval, times e to the minus j k 2 pi over 3t dt. And then I also have what the integral from 1 to 2, and x is 1 in that interval. I'll go ahead and write it in. E to the minus j k 2 pi over 3t, and then dt. And then over the last interval from 2 to 3, x is 0, so I am done. I don't need to integrate 0 times anything because it's just 0. Alright, so now the first integral, I'll put the 1/3 out front here. We end up with 2 over minus j k 2 pi over 3 e to the minus j k 2 pi over 3t evaluated from 0 to 1 plus 1 over minus j k 2 pi over 3 e to the minus j k 2 pi over 3t evaluated from 1 to 2. Close brackets here and move this up. Alright, so now e to the jk 2 pi times when t is 1 is just that, so we have 1/3 times the quantity, 2 over minus jk 2 pi over 3. Value at the upper limit, you have e to the minus j k 2 pi over 3 minus e to the 0 is 1. For the second one, I have plus 1 over minus j k 2 pi over 3, and I will clean that up eventually here, times, evaluated at t equal to 2, e to the minus j k 4 pi over 3 minus e to the minus j k, value t equal to 1, 2 pi over 3. Close parentheses and close brackets. Alright, so now move this up a little bit more so I have room. So first of all, I notice that there's 1/3 out front. When I make this a proper fraction, this 3 moves to the numerator. Likewise with this 3. So the 3's are actually going to all cancel. And then the other thing I notice is I have an e to the minus jk 2 pi over 3 here. And I have a negative e to the minus jk 2 pi over 3 here, although they're scaled by different things. This is scaled by 2 over this, and This is scaled by 1. So effectively I'm saying 2 of these minus 1 of these. So I can simplify this. Again, the thirds I'm going to cancel out. And then I have now 2, do the 1 first. So I'll have negative 2 over negative j k 2 pi. That's from the 1. Negative and negative. They're actually going to cancel. And then I have plus 2 over negative, or negative. So minus plus 2 minus 1 is just negative 1 over j k 2 pi times e to the minus j k 2 pi over 3. And then the last thing I have is minus e to the minus 1 over jk 2 pi times e to the minus jk 4 pi over 3. So another minus 1 over j k 2 pi, that's a k, sorry, e to the minus j k 4 pi over 3. Alright, and this doesn't apply when k is equal to 0 because I've got a k in the denominator. So it's looking back at our signal. We see, again, I'll sketch it down here. Over one period, it's 2, and it's 1, and it's 0. So 2 plus 1 plus 0 is 3, and divided by the period, which is 3, and you end up with a sub 0 is equal to 1. So this is equal to a sub k, k not equal to 0, and you have the, when k is equal to 0, you end up with a sub k is a sub 0 is equal to 1. Alright, so that's it. Thank you.